In this video, we'll show you the power of Gemini Vision API and how to use it in your Python programs. We'll start with basic image understanding. The API can caption and answer questions from images and PDFs. We'll then move to analyzing multiple images, detecting objects and scenes, and finally, segmenting images like a pro. Let's go to our code. As always, we first import the necessary packages, load our API key from .env file, and initialize our client. If you want help with setting up the environment and installing packages, watch our first video in the playlist. There are two methods to input images. First one is using the Files API as shown on the screen. You first have to upload your image to the Files API as shown. The API call is made using this generate content function. In the contents argument, you pass a Python list containing the image and your prompt. We're using the Gemini 2.0 Flash model. You can use other Gemini models, but make sure it supports image or multimodal understanding. To learn more about Gemini models, watch our video on Google AI Studio. Let's run this. The model explains the image content and has provided a few captions with different moods, such as reflective and playful. The second method to input images is by passing image inline as data. For this, you first have to import the types package, then read the image as a binary file. Then use the from bytes function to encode image data as base 64. If you want to pass an image using its URL, you still use this method. We're using this image from Pexels. First, get the file using requests API. Convert to base 64 using from bytes function and pass it to the generate content function. And here's the result. It correctly identifies the flower and describes the image as directed. We use this API to understand a doctor's prescription. And here's the result. It accurately reads the prescription and provides the diagnosis and recommended dosage for each medication. Note, it is recommended to use the Files API if you're uploading images greater than 20 megabytes, or if you want to reuse the same image multiple times. It's different from reading an image file from your device storage. Check out the docs here to read more about this. Now let's see how to work with multiple images. We have these two images of Eiffel Tower. We'll upload one image using the Files API and pass the second one as inline data. Remember, the contents argument always takes a list that contains your prompt and all the images you want to upload to the API. The model explains the content of two images and provides a detailed comparison as requested. To show you the accuracy of the Vision API, we'll upload two signatures and see if it can identify if the signature is genuine or forged. The model provides an analysis of the images, marks it as genuine, and explains its reasoning too. The Vision API also demonstrates strong spatial awareness. For example, we uploaded an image of an empty room along with a sofa and asked whether placing the sofa in the room would block the window. The model accurately understood the layout and provided a spatially aware response. This has tremendous potential in VR applications, intelligent warehousing, and analyzing 3D maps. To take full advantage of such capabilities, especially with structured and actionable outputs, check out our tutorial on how to get structured output from AI APIs. Now let's move towards advanced image analysis. We'll see how to detect objects and create bounding boxes as well as labels in 2D. All you have to do is write this prompt, explaining the output format and instructing to add labels and bounding box coordinates for detected objects. It's that easy. Use structured output to get a more controlled and consistent output. Remember, the output is text only with bounding box coordinates. If you're using this API in the AI Studio, it'll provide a labeled image to show you how it works. On their documentation page, you will find this Colab notebook, where they've explained image segmentation by masking objects and creating bounding boxes in 3D in more detail. Let us know in the comments if you want us to cover image segmentation in the upcoming videos. So far, we've learned how to use the Gemini API with image inputs for image understanding, image comparison, spatial use cases, and object detection. Check out Google AI Studio to try the vision capabilities and other models without having to code. If you enjoyed the video, like, share, and subscribe to the channel for more awesome videos, and check out other videos in the playlist. If you want to feature your AI tool, mail us at collaborate@aidemos.com.